The future of space warfare: how SpaceX and NASA are shaping military technology. Space technology has aided military operations and has established its place in national defense. There is a dire need for Pakistan to exploit this military tool for the balance of power in the region. Space technology is changing the face of military warfare, and the contest for dominance in space has increased its pace. The same has been a neglected part of the national policy of Pakistan and has not received its prioritization yet, despite having an early start on this front. This article focuses mainly on the current performance comparison of Pakistani-leased satellites with Indian indigenous developed satellites. If Pakistan does not plan to keep pace with India's fast-growing space technology, it may result in disastrous results in the future, keeping in mind the history of wars between the two countries. The authors suggest that an inclusive, steady, and strong national space policy on the part of Pakistan should be articulated and executed. Keywords: militarization, space technology, space program of Pakistan. Introduction. With the launch of the first artificial satellite, Sputnik 1, in 1957, the Soviets set the stage for the space race. Cold War rival America followed suit by launching Explorer 1 4 months later. 1 This started the never-ending queue of satellites. In the initial stages, national prestige was the predominating factor that motivated nations to explore the new front of warfare, and later critical military applications of satellites and missile developments led nations to pursue the development of satellites and satellite launch vehicles. The Sino-Pakistani nexus in the space domain covers intelligence, surveillance, and reconnaissance (ISR), and satellite navigation services. While Beijing has extended cooperation to Pakistan in the areas of space exploration, science, and astronaut training for many years, the Chinese plugged Pakistan into their indigenously built Beidou satellite navigation (BDS) system since 2013, which is China's equivalent of the American-built Global Positioning System (GPS) network. 2 Conversely, Russia and India have undertaken joint ventures in missile development. Russia and India have a relationship that has endured for decades, benefiting India in its space exploration and its attempts to widen its portfolio of defense and strategic partnerships. There is a legacy of Russian military equipment in the Indian inventory across all the services, including nuclear systems. In the following years, many civilian and commercial applications of satellites were identified and extensively developed. 3. On one hand, civilian satellites are used to generate awareness and uplift the socio-economic conditions of people living in far-flung areas. 4. On the other hand, military satellites are used for providing real-time reconnaissance about important enemy installations, intelligence about enemy deployment, battle damage assessment, missile launches, or even hunting down terrorists. 5. Satellites have enabled military commanders to get first-hand information about the likely target. Recognizing the growing potential of satellites and satellite launch vehicles, many nations of the world initiated their national space program, and Pakistan was no exception. It is vital to understand the role of space technology and its military applications with particular reference to Pakistan. 6 Considering its Indian-centric approach toward national security, Pakistan needs to re-evaluate what it considers to be a national security concern. If Pakistan is unable to introduce a cohesive and comprehensive national space policy, it will be difficult for the country to match Indian space efforts in South Asia, especially when India, with its hegemonic designs, aims to use space as another pawn in the regional gamble for dominance. As space technology is a vast field, however, efforts are being made to understand the importance of satellite technology for Pakistan to counter a potential threat from India's fast-growing space technology. Pakistan's space program, history and steps forward. Pakistan's space program was initiated with the establishment of the Space Sciences Research Wing under the Pakistan Atomic Energy Commission (PEC) in 1961. The wing was set up on the advice of the scientific advisor to the President, Professor Abdus Salam, the only Nobel laureate from Pakistan. 7 However, in July 1964, the wing was detached from the Pakistan Atomic Energy Commission and placed under the direct control of the President of Pakistan. Later, In March 1966, it was reconstituted as a separate organization and functioned under the administrative control of the Scientific and Technological Research Division. 8 Space Organization was granted autonomous status, and the Pakistan Space and Upper Atmosphere Research Commission, commonly also known as SUPARCO, finally came into being in 1981. The same year, the Space Research Council was set up and headed by the President of Pakistan, who was later replaced by the Prime Minister as head of the council, while SUPARCO remained under the administrative control of the Cabinet Division for almost 20 years from May 1981 to September 2009. It is interesting to note that during this period, only one meeting of the Space Research Council was held in 1984. Afterward, no meeting was conducted until the dissolution of the council. Finally, in December 2000, the Space Research Council was replaced with the Development Control Committee, DCC, and SUPARCO was transferred from the Cabinet Division to the National Command Authority. 10. Pakistan's launch capability started when a batch of Pakistani scientists trained by the National Aeronautics and Space Administration, NASA, became involved in building sounding rockets. 11 Pakistan was able to launch the meteorological rocket Robotai within 1 year of its inception and became the 10th country in the world and 3D in Asia to attain such a capability. 12 The two-stage rocket, Robotai, was sent 130 kilometers in the atmosphere carrying 80 pounds of payload. 13 After a month, Robotai 2 was also successfully launched. The data received from these rockets enabled scientists to gather information on wind shear, cloud formation, cyclones, and weather formations over the Arabian Sea, and, by 1972, Pakistan had carried out 45 rocket launches. 14. As compared to launch capability, Pakistan's journey in the field of satellite technology started quite late. SUPARCO first built a small radio satellite, named Badr-1, in the late 1980s with the help of the Pakistan Amateur Radio Society. 15 Since the satellite was planned to be launched from the Challenger OV-099 space shuttle, the launch was delayed due to the explosion. 16 Badr-1 was finally launched into low Earth orbit by a Chinese launcher in July 1990. It weighed 52 kilograms and was inserted into a 205-kilometer orbit. 17 Although Badr-1 could not complete its designed lifespan of 6 months due to technical malfunction, the voice and data communications from the satellite were successful. SUPARCO could not maintain pace with further developments of the second satellite due to the economic sanctions of the 1990s. 18 Badr-2 was launched in December 2001 from Kazakhstan on a Russian launcher. It weighed 68 kilograms and was inserted 1,050 kilometers above the Earth into orbit. 19 The progressive improvement in Badr-1 and 2 enabled scientists to develop basic expertise in the field of satellite making. Then in 2003, PakSatI was relocated to an orbit over Pakistan.